Thank you all for joining us at this meetup, the first meetup in the new year, the Mendix meetup. Glad to see we have a big audience despite the weather. Good to see you all. I hope you have enjoyed a nice dinner once again and that you are ready for the future of the smart buildings. My name is Anthony Dickinson. I work at Conclusion. The agenda for today, I will do the opening, be sort of the master of ceremonies for tonight, introduce the speakers. Next up will be Jan Vries, community manager, building the Mendix community. He will have an update about the meetups that we have scheduled for the upcoming period. Some slight changes in respect to last year, and also a small quiz if I'm correct. Yeah, all right. It's not limited to the meetups, but also something about Mendix World. So stay tuned. Next up will be Gertjan van het Hof, part of Conclusion Connect as a solution architect, and he will guide us through building a platform using Azure and OpenStack to create those smart buildings as well. And last but definitely not least, he's back again, once again, Dirk Huibers from Octo. Gave a presentation about 2 years ago, if I'm correct. Some interesting developments, product development as well. So looking forward to where you are now and what you can take us along with in the journey of smart buildings. Well, we all know our smart homes, where we can just talk to Siri and Google Home and turn on and off your lights. You can also have some sensors in your house where you can turn on some lights. Makes it very easy for us, but well, it's sad to say it's not really that smart. You can have all kinds of things, some smart appliances. Last year our washing machine died, so we now have a smart washing machine. It sends me a notification when the wash is finished. Unfortunately, it doesn't fold and iron itself, but that is something that can happen in the future perhaps. But there are all kinds of smart appliances, things in our life that can make things more easy for us. But that's on a consumer level. So I'm looking forward to the smart buildings presentations about Gertjan and Dirk. How can we change businesses using sensors, information, bringing it all together, gain actionable insights, and make life and business easier and more comfortable for us as well. So now I will give the floor to Jan, and he will guide us through the Mendix meetups.
Yep. You got that presentation?
Yep.
Thanks, Anthony. It's really great to see everyone here. I remember the last one we did in December in the Rotterdam office, and it was an even bigger crowd. A couple of people had to cancel because of the snow. Some were stuck in traffic, and the navigation said 2.5 hours. So I said we would save some food, but unfortunately I could not entice them to join us. But what I want to talk about is some of the things that we have planned for community in 2019. So I want to start off with one thing, the number 11. What do you think that number represents? November. Yeah, that too.
Amount of meetups?
It's the number of meetups that we organized in the Netherlands in 2018. So that's pretty much every month. I think we skipped one in the summer or something. I don't know. What about 96?
Presentations?
Yeah, so it's close. Yeah, average number of signups that we get for all the meetups. And that is really, really high. And that means the community is incredibly engaged. So good on you guys. And there's one more thing. 4.8. That's the average rating that everyone gives to the Mendix community meetups. So, you know, everyone who decides to go to the meetup generally likes the meetups. So who's here tonight for the first time? Wow. That's 15, 20 people? That's really a large number. It's great to see everyone. Welcome. I hope you have a great time tonight with the presentations. And what we're going to do with the meetups in 2019 is, because there is so much interest, we're going to double the number of meetups that we're going to organize. And not just in Utrecht or Rotterdam or Amsterdam, but also in other regions. So we'll be hosting one at Apronto in Breda, but we'll also host one in Enschede at Cape, and in a lot of other regions as well. Now, the whole calendar is already filled up until June, but if you want to organize or have an idea for a meetup, just come to me and we'll talk about the agenda and see what we can do. Next to that, you may have seen the camera when you walked in. One of the things that we want to start doing in 2019 is live stream all the meetups and record them, because we've had a lot of requests from people saying, I can't attend the meetup, or I'm at a different location or in a different country, but I would still like to consume the content. And they are right. The content should not be locked. It should be free to everyone. We want to help everyone and the community build better apps. So that's what we're going to do in 2019 as well. I believe for this one, it's a test run, so we didn't announce it up front, and I believe we have the image for the presentation, but not the actual live image. So, lucky for me. And that brings me to Mendix World. Now, I think most of you already heard that we're going to do Mendix World in 2019, on April 16 and 17. And if you look at your flyer, there's I didn't bring enough actually, but on the back is a taste of what's to come at Mendix World. So there are categories here and a list of topics that we want to cover at Mendix World. And what we like to know, and what I'd love to talk to you about after the presentations, when we've had a beer, maybe 2 beers, is what your ideas are about these presentations. Is this something that you want to see at Mendix World? Is this what would make you attend? Or maybe you have a brilliant idea that we haven't thought of yet, that you say, you must do this at Mendix World. So I'd love to know what you think. Yeah, have a look at it. Have a look at that. Now, there's one more thing. We had a Christmas challenge to build a Christmas app to help Santa, and 300 people participated in the contest, and there's one winner, which is Tim van Steenbergen. But has anyone seen Tim? Because he signed up for the meetup, but see, it's kind of a shame because he's gonna miss out on all this cool swag. So I guess I'll have to take. Yeah, well, I guess I'll just have to save this for the next one. Yeah? Okay. Don't open it. Yeah, so that's it for me. I'd love to talk to you after the presentations about Mendix World, about what you do with Mendix, what you build, and yeah, what you think of the meetups, and what you want to see community do in 2019.
Right?
Yeah.
Well, thank you very much, Jan, for the update about the meetups and Mendix World. In meanwhile, I will create some more flyers, and I'll distribute them afterwards. Yep. So they will be available for everyone to have a look at. Next up, I would like to give the word to Gertjan van het Hof. As mentioned before, he works at Conclusion Connect as a solution architect. created several platforms rolled out at different customers, implementing the smart buildings, and also those platforms have a front end developed in low code in Mendix. So it's good to see what he can bring us.
Okay. Some switching.
Yes.
Sorry for that.
Yeah, let me just put on the microphone. Do you have a microphone?
Yeah. Okay, thank you very much. 2 weeks ago, Anthony called me to ask for giving a presentation regarding smart building. And of course, I said yes, and that's why I'm here. My name is Gertjan van 't Hof from Conclusion Connect. Actually, it's the part responsible for IT projects. And what I'm doing in my daily life is IT projects, of course, and in smart buildings area, and also in the manufacturing area, condition monitoring and that kind of things. And we're going to talk about smart buildings today. I'm talking about Mendix, of course, but I'm not an expert in Mendix. You are, but I'm an expert in bringing data from the sensors to Mendix. And I'm going to present 2 cases for smart buildings, and that's Azure. How can you bring sensor data with Azure from the sensor, from the local to Mendix, and what architecture should be there in place. And I'm going to talk about an open source stack, and I will mention the name later on when I'm there, so I will keep that secret for now. That's me, my LinkedIn, Twitter, and etc., etc. You can call me if you want to phone me, it's also okay, not at night, of course. I'm IT enthusiast, and I'm doing lots of things like that. Okay, smart building use cases. Anthony also showed someone, and this is an example of a building use case with lots of sensors, and the most usual things are temperature and that kind of things. Four important things we can manage with smart buildings is usage satisfaction. So the users of the building are satisfied. The room doesn't smell when there is a crowded meeting. The utilization is okay. And what you also can do is to bring the footprint of a building lower. To measure, for instance, the temperature outside and the temperature inside, and to compare that. And when there is some energy leakage, you can optimize your building, so bring the footprint lower. And another thing is when you measure how often a room is occupied and used, you can also reduce cleaning costs. Because when it's not very often used, you don't have to clean it very often. So that's also a business case for smart buildings. But how can we do that? And the concept is very simple, basically. There are 3 things you need. That is sensors who can generate data, temperature, occupation, humidity, CO2, that kind of things. Then you should be able to send it to a solution, usually a cloud-based solution. And from there, you need to bring something in place to bring insights. What type of data is it? What's happening? Are threshold exceeded? And then an action occurs, and you need something to respond to those actions. These 3 basic steps are needed in an IT platform, IT solution, also in a smart building solution. Actionable insights. What are actionable insights? If somebody has questions, don't hesitate. Raise your hand and.
Could you go 1 slide back?
Yeah, go, of course.
see you have three main topics to get in smart building.
Yeah.
But why is it smart? Because it's not getting info back, so it isn't like circle, so it isn't making it smarter. So it just sets something and then it gives a signal.
Yeah, it's smart. It is smart when there's some smart algorithm in place, which do the smart things and inform you about a threshold when a threshold is exceeding of that kind of things. So then it's smart. But we are going to look into that in detail.
It's not intelligent.
Yeah, it sounds like you mean self-learning.
Yeah.
Or
So like, what's the intelligence? Like now it just says like, hey, there's light in this certain room, but
or the temperature is too high.
yeah.
That's a little bit smart.
Okay.
Yeah. So okay, you need something in place to raise notifications on alarms, for instance, when temperature is too high or the occupation is too big or of the condition, the climate is not okay. Then you should raise an alarm. Could raise an alarm with a severity level. And what is needed is an end user should be able to adjust the severity level, because when you go to the room and find out, okay, that was a wrong alarm, then he should be able to set the value back from high importance of critical to medium importance of that kind of things. Or he must be able to add commands to the alarm. Okay, this is going on, and it's not an alarm, but it's something else. That's one of the things, capabilities, what are important in the platform. Another thing is the visualizations, and based on graphs, telemetry data, and KPIs. For instance, that kind of visualizations should be in place. Functionality, of course, to drill down to the sensor data itself from a top to a more detailed level. And something should be in place, and that's a digital twin. And a digital twin is an example of a floor map. It could be a digital twin. Where are the sensors? What is the condition in a particular room? Make it red when an alarm condition occurs, that kind of things. That should be also in place. When that is in place, you have actionable insights. And now we are going for an example. First of all, we have the sensors, and in the room there, next to the door, there's this sensor. You can find this sensor. And the sensor is measuring CO2, measuring temperature, measuring humidity and occupation. So when that's the first thing, and it will send the data by LoRa. Somebody heard about LoRa? A lot of people, some. LoRa is a protocol for sending data, small packages, and it can send it a couple of kilometers. So that's better, much better than Wi-Fi or Bluetooth technology.
Comparable to 5G or 4G, something like that?
The energy consumption of LoRa is very low. That's why it's used. You only need a small battery, which can last 5 years. So, and with 5G, that's not possible yet. So that's the reason to go for LoRa. You need a gateway and it's in the building on top, but there are lots of gateways for public to get the data and to send it to the internet, to make it internet connectable. In the example here, we work with the Things network. That's an it's an open source network for LoRa, for all LoRa devices. In there you can do the device registration and all the security kind of things. From the Things network, we built an HTTP integration with a cloud platform. And this presentation is I'm going to talk about two alternatives. One, the Azure platform, and the other one is an open source stack to build this. And then, of course, it will go to Mendix to make it actionable. That's the solution we are going to talk about. I made some design decisions. There's a lot. Digital twin in Mendix, visualization with Mendix charts, Plotly kind of things. No telemetry data should be stored in Mendix because of the large volumes. When you have a very big building, the volumes can be really large. I'm going to expose the data by APIs and also the alarms and alerts, of course. We need something for high query performance because Mendix is querying the data and making the graphs real time based on a query, so the database must be very fast. And we need something in place which will make it intelligent, and that's your question, and that is real-time anomaly detection. And LoRa sensors connected by the Things network. So, I already talked about the sensor itself. Temperature, humidity, light, occupation, 5 years, and 8 kilometers. Can send this data, clear field without buildings, 8 kilometers. So that's very big. It's huge, yeah.
What does it cost?
This one, I don't know, actually it's 60 euros, something like that. Yeah, approximately. Yeah. Okay, two alternative implementations. One is the closed source version with Microsoft Azure, and the other one is with Influx Data, which is a kind of open source. It's open source for single node, but when you need to cluster it, then you have to pay for it. Somebody familiar with Influx? I see some faces happily or not. Yeah?
Yeah, sure.
Okay. Great. But what type of data do we need? Here is from the DB engines, and that's a graph showing, a pie chart showing the types of databases and how much it's used in the field. And we are going to talk about a database. We have a kind of data in which almost every record is a new entry in the database. Because it's temperature data, it's time series data, and we don't need NUT dates. Every record will be a new record. And we need a database which is able to handle time, of course, in an ordered way, but it can be in regular intervals, can also be in irregular intervals, doesn't matter. And it should be able to handle a large amount of sensor readings, and then a time series database like Influx is the best option to do, because it's number one in the list for DB engines, is by far the number one in query performance, and so for write and read. And here's some comparison between Influx and Mongo. It's 2 times faster than Mongo for data ingestion, 20 times better compression. It does real-time data compression, and 5.7 query performance better than Mongo. So that's why we choose for the InfluxDB instead of Mongo or another database. Okay, now I'm going to talk about the Azure IT solution. First, we've seen the sensors, the gateway, and the Things network, and we have a couple of Azure Platform as a Service components. We have the IT Hub, that's the entry point. The device management is done in the Things network, and the cloud entry point is the IT hub, and that handles the security and all that kind of things, and route the data to a streaming analytics components who is capable of reading the data real time and search for anomalies. And what it also can do is data aggregation for a particular time window, for instance. And there's an integration can be built very easily with a machine learning PaaS service. In there, of course, you need to train first a model. I'm not going to talk about that, but when you're able to train a model based on the data, you can deploy it, and then in a machine learning service, and then real time, the streaming analytics can query the machine learning service and send the data to it, and the outcome will send back. And when a particular outcome is, okay, this is a bad condition, then the data can, then streaming analytics can act on that and send the data, for instance, to a particular database. It can be Cosmos. Now, based on top of that, we need something to make it actionable and to show it to the Mendix, of course. On top of Cosmos DB, you can build function apps, which are serverless computer services. For instance, you can build it with JavaScript, Node.js part of things. And on top of that, you need an API gateway for security, and Mendix is able to query the data from the Cosmos DB engine. So that's basically the solution when to do it with Azure. So this data is stored here, the alerts are stored here, the aggregated data is stored here, and you're able to query the data from Mendix by an API like this. Yeah, questions about that? Yeah.
Did you use only Cosmos DB as a data store, or were there alternative archiving storage solutions?
Yeah, of course there are more solutions. What you can do is make a separation between hot data and cold data. And archive data can be sent to storage, for instance. So there are more possibilities over here.
Yeah, especially
Yeah.
because Cosmos DB is quite expensive.
Yes, that's true. Yeah, that's correct. Yeah.
Okay.
Yeah. That's why in most projects I put here InfluxDB. But okay, I want to show a complete pure Azure example, and then you should use Cosmos DB, of course. Yeah. Yeah.
Where's the InfluxDB from the last slide?
The InfluxDB will come in the open source solution, which will I present after this. This is a pure Azure PaaS solution, and you can combine both solutions, of course. Yeah.
I see a lot of components.
Yeah.
Can you say something about the robustness of this kind of implementation?
The costs?
Robustness.
The robustness. They are full managed. What it means is that that Azure is taking care of it. So when something is failing, then another can take it over. It's full redundant, and you can scale it easily by it's just a number to stream or to add more units. Just fill in a number in an admin page, and then it is available. The Cosmos DB is geo redundant also over different data centers in different worlds, if you like. But then it will become very, very costly. So yeah. Yeah, back.
Function apps is also the part of this landscape that turns down the heating.
That turns
Down the heating.
What do you mean turns down the heating?
Control actions.
Control actions. Yeah, you can. If you as you can see, it's a bidirectional thing. Yeah. So in Mendix you can type in or do particular actions, and then it can be saved over here, of course. So it's a bi-directional API. Yeah. Okay.
Function apps is the app on the washing machine, for example, if you want to start that remotely.
The washing machine
Yeah, if you have a
is there.
yeah, that's
Yeah.
a sensor.
That's a sensor. Yeah.
But if you want to activate something,
If you activate something, okay. I didn't show that here. Yeah. But what also possible is okay. Yes, the IT hub can also send data to that, to the sensors, if you want. Yeah.
So then you go from the function apps to the IT hub.
Let me think.
You want to make
Yes. Yes. Yeah. That's correct. Yeah.
the AI would put something in the database like turn down the heating, function apps picks it up.
Yeah.
Sends it over back to the IT hub.
Yes, that's correct. Yeah.
All
Yeah,
outside
yeah.
Mendix.
Yeah.
Okay.
Yeah.
And how
Good
do
point.
you display the alerts in Mendix, or where do you display the alerts? Is it in Mendix?
Over here. Yeah.
So you push them.
Now, in this example, there's not a real push, but you can push from here.
Okay. But
Yeah.
now you have to tweak all the alerts. Give me the alerts from last hour or something.
Yeah. Yeah. It's more the aggregation thing. Yeah.
Okay.
Yeah. Good question. Yeah. Okay. The other solution is the influx data solution. We begin with the same starting point, and that's the sensor and the LoRa and that kind of things. And this is an example. This is not from Influx. This is an Kong. Kong is an open source API gateway. There are lots of alternatives, but I've chosen this one because one project we did, we selected this one as the best, so that's why it's there. That's the entry point of the solution. You need something in place for security and for that kind of things, and Kong will handle that. Then the data is sent to the Influx tick stack. And there's a couple of components they are delivering. We are going to look into that the next slides. And it's from Influx data. And on top of that, of course, you need something with machine learning. TensorFlow, and the next presentation is going to talk about TensorFlow a lot, I think. No? A little bit? But okay. Also here you can integrate with TensorFlow or LoudML. LoudML is something which is on top of TensorFlow and is fully integrated in the tick stack. So that's why it's on this slide. There you can define your machine learning models and the Jupyter notebook and run it in a Docker container with TensorFlow, and there's an integration with Influx data.
John, where is this hosting?
Can be everywhere,
Okay.
every cloud.
But it's not managed.
You can buy it managed. You can run it in your own stack and where you want.
That's also Azure, for example.
Yeah, can be. Yeah, AWS doesn't matter. Yeah. And for the connection to the Mendix, yeah, you also need an API gateway. Could be Kong, of course, and a Node.js, and everything is managed by Kubernetes Docker containers. So these are Docker containers. This. So that's an alternative. When it's single node, it doesn't cost you anything except the Docker infrastructure, which you run in the cloud. The rest is very cheap. When you look at the stack itself, first of all, we have the data storage. That's the Influx, the telemetry database. It's purpose-built for time series data. Can be clustered, of course. And the ingestion of data is managed by a component which is called Telegraph. And Telegraph is having an HTTP. You can configure an HTTP endpoint, and that one we are using here. So the TTN network will send the data to this endpoint, which is actually the Telegraph plugin for HTTP, and that will send the data to the Influx database. And everything can be connected to this. 200 plugins are available for Telegraph. So you can also use it for monitoring your whole cloud and that kind of things, or monitoring your premise, what you like. The streaming analytics is part of the component capacitor, and also there you have possibilities to connect other things. For instance, here, oh sorry, one too quick. The machine learning and anomaly detection, which can be done in TensorFlow or another open source machine learning environment or framework. TensorFlow is actually more a framework to build machine learning. And one part of the platform itself is the chronograph. That's looks like a Grafana. It's a dashboard. Not very actionable. You can't type in anything. It's only showing the data for an ops user or what you like. And that's why you need something to make it actionable. You need something like Mendix to make it really actionable. The user should be able to do something with the data, to say it's correct, it's not correct, if the severity is okay, or to switch down, switch off a motor or something like that. So what we did, here we built a demo, which is of course this. But we did more. We also integrate with the open weather map, and that's the outside temperature. It's in REST API. Data is sent to Telegraph, and also the data is backed up for open weather, and it's saved in the Influx database. And what I did is I created a chronograph dashboard on top of it, and Anthony built a Mendix dashboard on top of it. And I want to show that to you. Oh, you can't see it because I have to move this, of course. Yeah. What you see here is the chronograph dashboard, the room temperature, the humidity, the room usage, if there are alerts, and that's a counter of the people which are entering in. It's not this room, actually, this is another room. And if there is an alert or not. And below there, you can find all, oh, how can I do that? Here it is. Data from the outside. The ambient temperature was, it was a little bit, it's where it is, let me see. I think I have to press F5 first. Or not. Yeah, it's okay. Yeah, it's okay. It's -1, I think. Yeah, it's the same as here. It's -1 outside. Yeah.
So, question: the process that you just showed, how much time did you actually spend on writing actual code to try to get the lower connectivity?
Can you repeat the question?
Yeah. The question was how much time I spent building the code to this. Yes? Okay. Good question. I think first of all, I need to learn a lot of things. So when you are experienced, you can build this in one day. Yeah. So.
How long did it take you?
You? Yeah. With all the learning curves and that kind of things. Yeah.
So let's
I'm
say someone
yeah.
in the room
Wants to start
wants to start doing that.
and from scratch, yes, it will take a week, I think. Yeah. Not a lot of code, no.
Tweaking them.
Just some configuration in some configuration files and select statements, and the rest is declarative over here. You don't need to build something here. You can get this out of the box. You only have to specify the select statement and what type of graph you want, and then it creates it for you.
Is there any way you can find your guide how to actually get it to work?
No, I've not documented. No, it's no. Probably in a blog sometimes. Yeah.
That's something we can work on.
Yeah.
This is the Mendix project. This dashboard. Or no?
This is not the Mendix dashboard. No.
That's not possible in Mendix, so
Yeah.
Yeah.
I wondered in a week. Oh,
Yeah.
what am I doing wrong?
This is the Mendix one. Yeah.
So
He built it today, I think. Or not?
Gertjan just gave me the endpoint and said, well, this is a REST service, just implement it. And that's basically what I did. It wasn't the easiest REST service to implement because it has dynamic columns and dynamic values. Can you get the microphone?
Can you take it? I can't see it.
Yes, as I mentioned, it uses dynamic columns and dynamic values, and Mendix likes to have strong type data model to use it in their import mappings. So with some tricks, I managed to get this to work in, let's say, half an hour. That's basically giving you two graphs.
Yeah.
That's basically it. The most difficult thing was to get it with get the authentication to work. In the end, we created a new user that was able to authenticate. So, yes.
Are you querying the data from the Mendix app, or is that part of the
Influx.
focusing app?
So the Mendix application doesn't store any data.
Yeah.
It's executing a query on the Influx data database. We retrieve the result from the REST service itself, and we process it and create this graph.
Alright, but you're not limited when creating that query, for example. So you can just query all the data you need and show
Yeah,
it in the
that's correct. Except when you have an API, a strong API on top of it, then it's not possible anymore. But in this solution, you are able to send a select statement to the platform. Yeah.
Does Mendix provide an out-of-the-box option for using WebSockets, so you can push your data into the graph?
I don't know. I'm not a Mendix expert. I have to look at you guys. You should know that.
It's not it, no.
No. No. Okay. Okay, it's pity, but okay.
So I have two requests.
Yeah.
Request and how-to request.
How to is the second one. Okay. I will close this one. Yeah. Close tabs. Okay, there's this one. Some use cases. We also build more, of course. And when you are in the lobby and there's a huge screen, you can find this one. And what you see here is all 5 rooms we are monitoring. We've put sensors on that in each room, and these are the names of the rooms, the humidity, the temperature if there are alerts, and the light intensity. And we are using this to measure the occupation. Sometimes a room is booked. It's a meeting room. It's booked, but not used. So we are going to make it more and more better, more actionable. There will be in the future there will be a list showing, okay, you booked, but never come. So that's an alert. So we can call him, okay, don't do that anymore. That kind of things. Yeah. This is built in Grafana. Another use case we're doing for a customer is a school, and we are also measuring the humidity and all that kind of things, the climate in the school. And when everything is wrong, it will be red.
Is this real?
This is real. This was a test case. This was a test case. Yeah, not real. Yeah.
How accurate is the data? Because the LoRa is here also next to the door, and it's not the most perfect place to put a sensor next to a door that's open. It is for counting people, but it's not for the draft, temperature, and all these kind of things.
Yeah, for temperature is okay, but we also used more accurate sensors above the door to see if someone is coming in or coming out.
For temperature, it isn't the best place.
And for temperature, we put it on the wall or on the ceiling.
So it's the sensors. This is just like the other sensors are overruling the sensors in the LoRa, or
The LoRa itself is just a communication protocol.
Okay.
Yeah. So the sensor is sensor sending the data by LoRa. Yeah. What the funny thing about this topic is every 6 hours in 6 hours in the morning, the heating was switched on, which was too early. They found out, and they saved a lot of costs to switch it a little bit later. They didn't know that the heating was 6 o'clock on. They didn't know that. And because of this, they measured, okay, it was too early, so we can switch a little bit later. Yes?
Do you make a difference between real-time actionables and overtime actionables?
No. That's possible, of course.
Database, and your data stream can immediately send a signal back to these functions.
Yeah.
But then you can, if you're able to configure your real-time actionables on your data stream, I don't know exactly how that works in Azure. What kind of logic there is between the AI and the data stream?
Yeah, that's real time.
Yeah.
And then you can do something. Yeah.
Only the real-time measurements.
Yeah.
And then the overtime actionables, you can do that on the other end of the database.
Yeah. You can separate the solution into parts actually, in the real-time thing and the overtime thing, that kind of things. Yes, that's possible. Not in place in this platform, no.
Yeah, I have a question. At home I'm playing around with Demotics and OpenHab and that sort of stuff, and a lot of things work correctly, but when I talk to suppliers of building automation systems, they're very, very hesitating that you can access their data or their systems. So we got a new building in Rotterdam. I'm working for the Hogeschool Rotterdam, and they are not allowing anyone to access their control system because they're very much afraid you will disrupt it. What's your experience with suppliers of building automation systems?
Yeah, first of all, of course, you need a pen test of that kind of things on the sensor.
Yeah.
So you need to hire something who's able to do that.
Does it actually integrate to existing buildings on the building automation infrastructure?
What do you mean? The integration with?
You build a building like this, and some people are doing engineering, and are you going to talk with them about what you're going to do with this system?
Yes, of course, yes. But usually what we do is to put new sensors there. But sometimes some newer buildings already have sensors, but we are not, at the moment we are not using them. Yeah. So we're supplying the whole solution, including the sensors.
Okay.
Yeah.
What is this tool? Is this also Grafana?
No, this is Power BI.
Power BI.
Yeah.
Okay.
Yeah. here's an example of how it looks like in a graph, just for to show different visualizations, and also we also measurement the toilet usage, sensor on the toilet. So for cleaning is also handy when it's very often used, and some toilets on some floors are never used. You can see it over here. This one is very often used, but those less, much less. So you can skip those probably, or close those, and most people like this one. Yeah.
But it could also be that a toilet is broken or something wrong.
That I don't know. No.
Do you measure water consumption?
No, here this is usage, just entrance. Yeah, yeah, yeah. Okay, some takeaways, and then I will make the floor for somebody else. Open source products are usually single node, and you have to pay for that if you want it full, high available, and clustered and scalable. So you must aware of that when you're trying to use single node. But single node can handle lots of data. So in most use cases for buildings, single node is okay. Most use cases, the availability is not needed to have it on a very high level. So that's okay. The speed of implementation with Azure services was higher than the open source alternative. It was especially when you add machine learning and that kind of things to it. With Azure services, much more easier.
It's just usability of the components?
Yeah, and it's integrated and less technical.
Okay.
So that's why Azure's time to market is higher. Machine learning environment of Azure is closed, and there is an alternative in Azure which is called Databricks, but that is very technical. So if you want to do that and you want to do more complex things, you can use Databricks. But okay, the learning curve is much higher in that case. And cost-effective solution is with tick stack and TensorFlow or LoudML, that kind of technology. On Docker, that's cost-effective. And when you need real nice machine learning cases, you can use TensorFlow, which is a framework for doing that, which is quite mature, and with Jupyter Notebook, where you can specify your models. And to make it really actionable, you need something on top of your platform. It could be Mendix, which is of course low code, but complex visualizations can be problematic. So probably you need to combine that with other tools like Grafana to make deep dives in your data and other visualizations. But for making actionable to react on conditions and alert, Mendix is and visualizations already showed in the demo. It's okay. Okay, that was my my talk. Some questions.
Can you give an example of a more complicated machine learning case algorithm that you needed?
Yeah, there are lots of in the industry, for instance, failure of motors. What we do is in the industry we are putting sensors, vibration sensor on top of motors, which is part of a plant, and what we did is to talk with the condition monitoring experts. When they look at the graphs, the vibration graph, they are able to say, okay, this and this is wrong, and to set that algorithm what's in their head in an algorithm which is executed by machine learning. I didn't do it, and a colleague of me did it.
Like providing the values to monitor. So what's the learning? What's the machine learning aspect?
The machine learning aspect is to find the algorithm to find the anomalies in the data.
It sounds like more if it's above or below a threshold, then it's an anomaly.
Yeah, that's the easiest one. Yeah, that's the easiest. For that case, you don't need machine learning. But to find out in a spot when you have different vibrations in different axes, and the machine learning expert is able to find out what is going wrong. It can, when it's looked at the graph, he can say it. To put that in an algorithm is much more complex than only a threshold.
Yeah, and you have encountered those cases.
Yes, yeah. Not myself, but a colleague from me. Yeah. But in the project we did, yeah.
Is there already some information about sensor failures? Because it's very nice if every room gets a lot of sensors, but hey, they will fail also.
Yeah, the idea is that each sensor is pushing a live message every minute.
But do we know how long they survive? Is that 5 years, 10 years?
Yeah, 5 years, but the project is quite new, so I don't know if it will last 5 years, the sensor, but hopefully it does. But when it stops the heart beating message, then you know it's something wrong. The other thing, of course, is the calibration. You need to calibrate if something is okay. So sometimes you need to visit the place if it still is okay.
Do the LoRa devices send their battery life percentage?
Yes,
Yeah,
they do.
that's no problem, right?
No, but it's possible they're sending the wrong value because they are broken or something like that, or they fall off the wall, or yeah, it can be anything. Yeah.
How safe is this protocol to? I can't remember the name.
The LoRa. LoRa isn't safe, but for that you need encryption, and encryption should be on the device itself, and in the cloud you'll be able to decrypt it. So that's the only way to do it.
Not standard.
Not standard. No, not yet. But they are working on that. Yeah.
How many projects have you done so far?
In the industry for one big client, and they are selling it to 11 clients, the solution. That's the industry case, and the smart building case is one, and they sell it to 2 clients. Yeah. Yes?
If you don't have a gateway within range, could you just put one up?
Yes.
Yeah?
Yeah, it's very expensive. It's good gateway is out 800, and you have a very good one.
Okay.
Yeah. Yeah, 200 can. Yeah. But
Well, my one was 200.
yeah. Yeah.
No, that's not all you express. Things like that. 200 you can do it at home.
Okay. Other questions? That's no.
No?
Okay. Thank you for your time.
Right. Thank you very much, Gertjan. Thank you very much for your
Yeah.
power. Yeah? Top. Okay. Hi, I'm Dirk. I'm one of the co-founders of Octo, and I'm going to tell you something about our smart building solution. I was just talking to our technical team that we must be doing something wrong, because we've been spending about 3.5 years working on the solution, and I just heard it could be done in 1 day, so maybe not listen too much to what we say, but definitely we'll be going strong for the past 3.5 years. And I will be focusing more on the business development side, which I think is going to be, Mendix is very strong at building quick products to test out a lot of stuff. So a little bit less technical as my colleague before, but hopefully as useful. We use 3 technologies. One is sensors. We buy them from all over the world. We use drones and AI to provide solutions for 2 different kind of categories. One is to support facility management, and the other one is to automate outside inspections of buildings, so to make inspections without people possible. But before I go into that, a little bit of a philosophy about how we look at IT, and this is IT from the 90s. So what we have is a pyramid, and on the bottom of the pyramid there's a lot of data. Think of large Excel sheets with a lot of numbers in them. And if you filter that data, you will get information, and if you make graphs out of it, as we just saw, you get insights. And we always used to have people looking at graphs, thinking, hey, what should we do? And then we will set them out into action. And what we see now is that the bottom of the pyramid is getting wider, and that's because the price of microelectronics is dropping significantly. So a lot of more devices are getting connected to the internet. But much more important, we are storing information not on our computer locally, but we are storing it in the cloud, of course, as you all will know. So we get a lot more computing power in the cloud. And what we get in abstract terms is that we get automated wisdom. So we don't need somebody looking at a computer to think, hey, what should we do? But the computer itself will think about the optimized action to take based on the data it got introduced to. But the most important thing for any successful project is what wisdoms do we want to generate? And based on that, we will make a plan to input data, and not the other way around. And that's why we see a lot of IoT projects fail, because they start with a sensor and they think, hey, what can we do with the sensor? But it should start with a problem, a business challenge, something like this, and then work your way backwards towards the data. So first, a facility management problem that we're dealing with. This is one of the biggest buildings in Holland. It's the new municipality building in The Hague. And we manage a performance contract for the BAM. It's a large construction company, and they have a dynamic contract here. And that's to keep the indoor climate always in a perfect condition. And what we do there is we measure, a little bit like my previous colleague said, every 15 minutes we take out all of the data from the building management system and from external sensors, the same as shown before. And we measure if they are within which threshold. And if the threshold sort of agrees with the one who was in the contract, and if it's yes, then it's good. If it's no, it's bad. And at the end of the year, we will calculate how much time they will be performing in or out of contract, and they will get a bonus or they will get a fine for not performing or overperforming. So 2 things are important here. One is that we connect with building management systems, and the other one is that we can place sensors when needed. We don't only do it with that kind of sensor, but we do it with loads and loads of sensors. So I have one here. So we started out with large sensors, but this is now the smallest one we buy. It's it's as big as a postal stamp. It lasts 15 years, the battery, and it costs about €3 per month. So it's really cheap. It's high performance, and it's very high accuracy as well.
What does that measure?
This measures technically differentiation in the magnetic field, or open-close to the layman's eyes, but you can also implement it in chairs, for example, to see if they're occupied, or in toilets, or windows for the security, stuff like this. Even in printers, to see if the printer it doesn't have any paper anymore, anything you can think of. But also, for example, flooding. So is a parking garage, is the little pump broken, and they will get water over there, stuff like this. Very practical stuff. 3.5 years ago when we started, there was only one sensor, and everybody bought the same thing, and now you see a lot of hardware coming up and for lots of different use cases. So that's very interesting. But if we think back of the pyramid, so this is the bottom of the pyramid. We get data, for example, from a occupancy sensor, and we show it immediately. And here you see us showing it on a 3D model. And then in red, there are, for example, desks who are occupied, and in blue, they are the ones who are not occupied. So somebody enters the building, and they can immediately see where there are available desks or meeting rooms or concentration rooms, stuff like this. If you go one level up towards the information layer, you get historical analysis. So, for example, in the past month was something in or out of benchmark, and in relation to what's outside temperature, you can sort of get into the analysis sphere of it all. And even one level more up, we go into semantic information, so text basically, and more preferably PDFs. It's all nice that we build nice apps and platforms, but our clients, they prefer an email in their inbox with a PDF, download it, share it, print it out, talk about it in a meeting room. Very, very practical, old school people that we work for most of the time. So this is the way they like it. But what's important here is that you get a lot of data from the bottom, and you start to summarize it in short amounts of text, which is understandable for non-technical people. That's the most important part of this. And from a data platform, so this is one of my 2 technical slides, so forgive me for the technicalities, but here you see how the platform is built. So we have one source layer on the right-hand side. Sensors, building management system, weather information, facility management information, for example. We insert that information into API gateway from AWS that gets pushed in either one of 2 directions. One is a real-time direction going here, and the other one is a aggregated direction. So the real-time direction is it goes into AWS Dynamo service. It will be written in a database. And then from a kinesis, it will get streamed towards the front end. So that's, okay, I push a button and I immediately want to see in the platform that this button was pushed. And the other one is, okay, of the past week, I want to see how much of the time was something within or without benchmark or something happened. I want to query the data. Then you want to enrich it, you want to analyze it, you want to combine it with other data sources. That's all done in Redshift. And together with Matillion transformation tool, and the cold storage is then done in a S3 storage base from AWS. And how we use Mendix, which is really important, is that it's the front end towards our client, but it also defines the context information towards the back end. So it will define, for example, the query on the AWS back end of us. So it's really a very fast way. The interaction between AWS and Mendix works really fine in that our users can self-define the queries that they're going to search on our platform. So that's good. And then they can export it from Mendix towards Excel or Power BI as just been shown. And it will also get feedback in towards the facility management. So you have this full circle from data source towards data source again. So that was number 1, the technical side. The second project I wanna show. I also want to talk a little bit about our development philosophy as a startup. But to do that, I want to define the word startup. It was basically invented a little bit by Eric Vries in the Lean Startup, and where it says a startup is a human institution where basically a bunch of people get together. They are really enthusiastic and they want to create something new, but they don't know what they are going to do, and they also don't know what problem they're going to solve and for whom they're going to solve the problem. So basically, Elon Musk, I think, called it walking into the looking into the abyss and eating glass or something like this. But I think it's a little bit more, can be a little bit more enthusiastic than that, but it's definitely going for it and not really knowing what you're going to go for. So how does a normal corporate do it? Basically, they get an insight. You see it on the right-hand side of the slide. Maybe we can combine blockchain with AI and then solve the world energy problem, something like this. And we are geniuses for thinking about it. So we have a solution, and maybe we charge 1 cent per kilowatt hour, and we have a business model, and then let's scale it, let's pump money into it and everything. How a good startup operates, between the insight and the solution, we will pose a problem. And we will ask ourselves, is this problem worth solving? And this is it might sound arbitrary to ask this question, but there's a lot of problems being solved which are really uninteresting to solve. The indoor climate one, for example, it's debatable how interesting it is if you cannot push back immediately to change the temperature, for example. So you should be really, really critical about how you're going to spend the limited amount of time we have as human beings on this earth and what we're going to work on. So this is an important question to ask yourself, and the only way you can answer it is by trial and error. So you really have to get out there, talk to clients, and see what piques their interest. And only after you've found something which really interests their philosophy, then you can start the business model and scaling everything. So in practical terms, how did we do it? We have one project. We talked to a facility manager. We were dealing with energy, and we said, okay, we're gonna optimize your energy bill by 10% with our smart building solutions. And he said, after 5 minutes of hearing me berate him with all arguments why he should do it, he said, well, I'm not really interested. My energy bill is so cheap. If I optimize it, I mean, it's not worth my effort, like at the end of the day. So I said, okay, no problem. Let's walk around the building. I just want to see what you're up to. What are your daily problems? How you're looking at things. So after a while, we came in contact with Henk. He's a facility manager of this building, and he's now rinsing this tub. Does anybody want to guess what this tub cost? Like what the price is of this bathtub? 17,000 euros. And a lot of the time it will be used as storage because there's Legionella in the bathtub. So what they have to do is fill out, this is a big folder of paperwork with this kind of papers in it. So the nurses of this nursing home have to fill out every week which shower or bathtub they have flooded, when and with what kind of temperature. Now, if you're a nurse, you're very busy taking care of people, and you're not so busy with filling out these kind of boring reports, of course. So it's a big problem. So that's interesting for us. It's a good problem to think about. So after a while of investigating and looking into the sensor market, we found something, and we found a water meter. So I called up Henk. I said, Henk, it's about 50 euros to buy this thing. You have to install it. It will be another 150 euros or 200 euros. And well, are you going to be my client? Yes or no? He said no, because I don't own the building. I'm the tenant, and I cannot screw in my pipes because if it starts leaking, they will kill me. It's a good price point, but I cannot do it. So this was a no. Second time I came back to Henk. I said, okay, now I have something. You don't have to install it into your pipe. It's an ultrasonic sensor, and it will measure, like with ultrasonic waves, the flooding through the pipe. It's 1,000 euros, this one sensor, so it's really, really expensive. And he said, okay, let's come to my office. We will talk about this because you're going all over the place, so we need to sit down and talk about this properly. He said, I don't only need the flooding, I also need what kind of temperature it was. So I said, well, Henk, if you're going to do two things, it's going to be twice as expensive. So it's already 1,000 euros. If you needed to choose, what would you choose? One or the other, flooding or temperature? And then was silent for a little while, and he said, well, I would choose temperature, because with temperature, if a pipe is standing still and somebody's going to take a shower, it will rise in temperature, and then I will see that this pipe has been used, and then it will slowly go down again, the temperature. So I said, okay, and the temperature sensors are really cheap, so we just cut down project development costs from 1,000 euros per sensor to 10 euros per sensor maybe. So this kind of conversation is very important. In the end, we developed this sensor. You can just click it around the pipe. It's very easy to fit on any kind of a thickness. And this is what it looks like in practice. A LoRa chip, as was discussed a little bit earlier. It will measure constantly. If it's water standing still, you will see it, and if you flood it, you will see it as well. And then in a Mendix app, the list of risky watering points will be presented towards the cleaning service, and they will flush the pipes when needed. And if it's not needed, if somebody has showered yesterday, they don't have to do it again. So that's how simple the solution in the end was towards this problem. And basically it was about asking the right question, and then with Mendix, developing a fast solution. Currently we've implemented at 4 buildings. So starting small hardware development is more difficult than software, because you cannot just push a button and say update if you made a bug, but you physically have to go everywhere to fix it. Still, but in the future it will be solved, that as well. At Friesland Campina, Sheraton, Vitens and the nursing home. And deliberately we chose 4 very different clients. So Friesland Campina is very different from Sheraton, for example, which is a hotel, and the other one is a manufacturing facility. But we want to make one product which works at all of the places, so we can scale up fast afterwards. And the ROI is always within 1 year. So that's a good business case. So then our last product, it's about automating outside inspections for housing corporations mainly. This is how they are doing it now. They are going door to door, measuring, for example, rot in wood or asbest in ceilings, all this kind of stuff. They will look. They have a way of inspecting a building, and they will calculate mainly using like Access database kind of programs, really simple. What we are introducing to them is measuring sensors and leaving them behind, looking through camera technology, drones or Google Street View or something like this, and calculating using AI. So this is, for example, a sensor which is mounted on a window frame, which measures the moisture level in the. It's basically same thing as the guy was pricking in Dutch. I don't know what's in English. Poking in the window frame, and then it will do an electrical shock, and the resistance in the electrical shock will define the humidity in it. If it gets too humid, then it will start to rot the window frame. So it's quite simple, logical stuff. Also another one which is really interesting. This is an RFID sensor. We buy it from the US. It's also used in nursing homes where old people piss their pants if they they have to get cleaned. And we do the same thing. It's no battery. We put it under the roofing material in order to see if there is a leakage, where it is, and if it can be contained in any way. So the first trial we did with it went horribly wrong, because it was totally set on fire. Basically, it's a very cheap sensor. It's like €3 or something. But it's not the end point of our service. This is where we begin to think. So now we are talking with the installation companies to already integrate it into installation frames, the sensors, so that they will we don't have to mount them afterwards, but they will be from the factory. Immediately the sensors will be inside the roofing materials. So that's from the sensor side. Yesterday we had our first flight with the drone. So that's that was a really big milestone for us. It's a drone which has everything double. So there's double the amount of propellers. It's a combination between the Intel infrastructure which is behind it and the camera. So we can sort of make a flight script and it will fly itself basically. And the output of it is a thermal scan of a neighborhood, which is quite low res, but it's very interesting to recognize, for example, weed plants for housing corporations, which is very expensive to repair, but also to make decisions on where to start insulating buildings where they leak a lot of heat. Also, a 3D model comes out of the drone, so they can sort of build a virtual building with it. And most importantly, photographs, and that's where we come in mainly. So of a facade, for example, what we do with it is one of 4 algorithms. So this is a little bit of the machine learning background that we use. The simplest form of machine learning is on the right-hand side of the slide. It's okay. We see a picture, and we're going to say something about the picture. So in this case, there is a window on the picture. So this is what Google did. There's like 1 billion photos of cats, and this was linked to each other, and then we have image recognition. So that's the first one. The second one is we're going to draw boxes around the window frames, and it's really a box. So we also have some excess material. It's quite a efficient algorithm behind it, so it doesn't take a lot of calculative power. The next one is that you draw like a polygon, very precise around the window frame, and the most precise one is that you draw a polygon, but you also separate the windows from each other. So that's the most intensive one, and you can say as a rule of thumb that's very efficient to calculate the right hand side, and this is very inefficient to calculate. So what do we do with the picture that I've shown before? We run it through our algorithm and we make a separation between, we actually extract like all of the building data from each other. Oh, question. No, the fourth one is hardest at the moment. It's because the trick is not really the algorithm. The trick is the data set in the end. It's you need a lot of data to do this kind of stuff. And some. Yeah, any one of them.
I mean, they have the third one?
Yeah, this one.
To go to the fourth one?
Yeah.
It's nothing, right?
No, this is not so difficult. No, this is not so difficult. It just costs a little bit more of calculative power. But to go from this one to this one is quite difficult at the moment. It's because it's basically because this algorithm exists for a longer time than this one. So it's newer. So it's been less developed in the end. So yeah, that's basically the reason.
And will it become more efficient if you feed it with more data? It will train itself, become better, and run more efficient? Or?
It will run more efficient. Basically the accuracy level will go up, and that's the most important part of it. But what we do to make it efficient is we use multiple algorithms next to each other. So what we do first is we separate the roof from the window frame, from the masonry, like every building facade element we extrapolate from each other, and then within the context of one element we start searching for something else. So within the context of a roof, it can be dirty. Vervuiling is Dutch for dirty, but there cannot be a deteriorating of paint, for example, because there's no paint on a roofing material. So you have your search list will become shorter in this way, because we only search in a specific kind of context. Within the context of masonry, you can have cracks, but you cannot have like the same dirt as on the roofing material, for example. So that creates an efficient algorithm, and that looks basically like this. So on the right-hand side, you have the picture. We get, if the drone flies half an hour, we get 2 terabytes of image material. So it's way too much. You never need that much of photos. So step number 1 is deleting a lot of data from the drone. But the second part is you have like 2 directions. Either you do object detection, so draw the boxes, or do semantic segmentation, and then within the semantic segmentation you can do another, like look for flaws. So you begin big and then you start looking for smaller pieces. Same as you do with your eye, basically. You also look for big stuff first, and then you start to drill down to specific areas. And at the end, if we found some flaws, we will push it back towards the original picture. And that might look quite easy, but it's quite difficult to do actually, because you need to georeference your data points. So if you see a flaw, you would also need to geolocate that flaw. So that's quite a difficult technical step. Basically, the drone helps us with that because it also georeferences the output. And in this, so the technical slide again, on the right-hand side we have the photos. It will be inserted into the API gateway. Then it will be sent immediately to the cold storage. From there it will go to the AWS Glue, and then to TensorFlow and OpenCV to do the image recognition, and then it will be pushed back again towards Mendix in the end. And there it will be shown towards the clients.
What's Medallion?
That's it's sort of a SQL generator. ATL, yeah. It's an ATL tool, yeah.
Processing tool for SQL, basically.
Yeah, so that's we use it a lot actually. It's quite a good good program.
Almost even expensive as Mendix, eh?
Almost as expensive as
Yeah.
Mendix. Yeah. If that's a good reference, yeah. So this is the team. We're about 12 people strong, and the young team and two of them more technical people than me are here. So if you want to have really difficult technical questions, go ask them later on. And if anybody wants to join our team, we're looking for front-end developers. So that's my recruitment pitch here. And we've been lucky to have a lot of clients who pay for about 60% of our turnover, and the other 40% we get from a European grant, an innovation grant. So that's what you see on the left or on the right. That was my talk, and if anybody has questions, ask them, please.
With regard to the drones,
Yeah.
what stage are you? Just at the initial stage, or have you got to the stage that you can convert, let's say, the observations to a maintenance plan, or
Yeah, we are working on that right now, also with maintenance software companies. So, for example, Ibis, Prognose, Fast. I don't know how familiar you are.
but not with the actual maintenance companies themselves?
Yeah, they are working with that as well. Yeah. So the large one, for example, Actionable delivers data for us to do our machine learning as well, and 10 housing corporations deliver data, construction companies as well. So yeah, we need the data. Getting the data is really the difficult part here, because, for example, we needed to go through 20,000 pictures in order to find 100 usable pictures for deteriorating paint, for example. So that's very intensive work. You can buy some off-the-shelf data sets from Amazon Turks, but it's very limited what they have to offer.
So when did Mendix come into the picture for you guys?
Basically, in the beginning already.
Yep.
So I was a business consultant. And then one day I had a idea I was writing big Excel sheets, and they were getting very slow. And then I asked one of my friends, Silas, who was sitting there, maybe we can do this more efficient. You're a software developer, you can do this. And he said, I can do it in one day. So 3.5 years later, we're still working on it. But we spent about 2 years learning Mendix, and like the core of the product was developed in Mendix. So a lot of the stuff is in Mendix, and then so the securities, the deployment process, everything is done in Mendix like this. But you need a scalable backbone like AWS to do. For example, we do a project with a very big online. Yeah, we're getting recorded. So. Very big online searching company for booking your vacation, and they get like a few million data points per day. So yeah, we couldn't push that through the Mendix server then, and so we needed to scale to Amazon. Yeah. Yeah, I think beers, everybody, or something. Yeah. Yeah.
Well,
Cool.
give me a round of applause. A few as well, a little present for
Thanks.
presenting at our
Yeah.
meetup.
Yeah.
I hope you enjoy it.
Yeah.
It's good to see you once again. Good to see that the. Sorry.
Yeah, I can meet. Yeah.
Is it live?